Hello everyone, Miss H here. This is actually going to be a shorter video. Today we're going to be looking at properties of bonds. So if you recall from our last video, we looked at the types of bonds being ionic, covalent, and metallic. This video we're only going to be looking at the properties of ionic bonds and covalent bonds. So let's start out by kind of defining the properties we're going to be looking at. So appearance is, what does it look like in its solid form? If I were to hold it in my hand or look at it under a microscope, for example, how would it look? Solubility is how well does it dissolve in water. Now there are some substances, especially some covalent compounds, that do not dissolve in water at all. They dissolve in fats or other things instead. Conductivity is how well does it conduct electricity. It also has to do with how well does it conduct heat, but since the purposes of our class, we're talking about conductivity typically in a liquid solution, we're going to stick with electricity. Flammability is how easily does it burn or catch on fire. And hardness is how brittle or flexible is it. So how likely is it to shatter when struck with a hammer? Here you can see a chart comparing the properties of ionic and covalent bonds. So ionic compounds are going to have a crystal form when they are in their solid form. So they are all going to be the same shape. They might be different sizes, but they should all have the same shape. They have a high solubility, which means that ionic compounds do dissolve very well in water. As long as the water is not too cold or fully saturated, more should dissolve. The reason for this is because ionic compounds have a positive and negative charge, and water is a polar molecule, so it has partial positive and negative regions, and those positive and negative are attracted to each other. Conductivity, so our ionic compounds are great conductors when they are dissolved, but they are poor conductors when they are solid. So if you were to put a conductivity tester into a jar of salt, for example, solid salt, it wouldn't really conduct electricity, but if you added water to that jar of salt, it would then be a very good conductor of electricity. Remember that pure water that has nothing added to it is a poor conductor of electricity. It's the reason why we tell you to get out of the pool or that kind of thing during a lightning storm is because of the fact that there is more than just pure water in the pool. Ionic bonds have very high melting and boiling points, which gives them a very low flammability. You're not going to be able to achieve the melting and boiling points for ionic compounds typically at household temperatures. This is something that's going to require much higher temperatures, usually in the hundreds to thousands of degrees. Ionic compounds are also typically very brittle, which means that they're going to shatter if struck. A good example for an ionic compound, as I already mentioned, is salt, like regular table salt, sodium chloride. And so if you were to take a big piece of rock salt or halite, which is the mineral name for table salt, the NaCl, that would be, if you were to strike that with a hammer, it would just shatter into millions of little pieces. For our covalent compounds, you have a much wider variety in their appearance as a solid. Some of them are crystals. Some of them are grains. So the difference between a crystal and a grain is just whether the shape is the same all around or not. So in a grain, they're more likely to be the same size, but they're going to have different shapes to them. So some might be cubic and others might be irregular and others might have a different shape to them. Whereas with crystals, they're all going to be the same shape. So again, covalent compounds can be crystals, they can be grains, they can have a more powdery appearance. They're going to have much more variety there. Solubility, as I mentioned on the previous slide, for covalent compounds varies. Some covalent compounds, like sugar, are going to dissolve very well in water. Again, as long as the water is the right temperature and doesn't have too much already dissolved in it, it will dissolve more. But then other ones, like our fats, are not going to dissolve in water. They're just going to sit on top. So again, it just depends on what the compound is. Regardless of which kind of compound it is, though, it will be a poor conductor of electricity, regardless of whether it is in a dissolved state or in a solid state. It's never going to do a good job of conducting electricity. It might conduct a little bit, but it's not going to be nearly as good. So if I were to put a container of salt water and a container of sugar water, and I used a light up conductivity tester, then the salt would be a really nice bright light, and the sugar might have a dim bulb to it, but most likely wouldn't even light up at all. Covalent compounds typically have very high flammabilities because they have relatively low melting and boiling points. These are the kind of melting and boiling points you can usually achieve in a household kitchen, and this is why you have to be careful with things like sugar in the kitchen, because it will melt and it will boil and it will burn very badly if it gets on your skin. So be careful with sugar in your kitchen. The last one is the flexibility. So we talked about how if I took a giant salt crystal and struck it, it would shatter into a million pieces. If I did the same thing with a giant sugar crystal, some of it would shatter, but a lot of it would more so flex and bend and stick to the hammer. So that is the covalent compound. Again, that sharing of electrons allows it to have more flexibility and more ability to move around instead of just breaking. Hopefully you found this comparison of the properties of ionic and covalent bond helpful, and I hope that you have a wonderful day.